Your foot and ankle it's complicated. The reason for such complexity is that your foot has a combined main role of being both very strong and rigid structure whilst also being a highly flexible and mobile structure to allow weight bearing, absorption and distribution of force, and also for function. The more moving parts, the better it is at absorbing force and dispersing force. And the more rigid the foot can be, the more efficient it is at releasing stored energy and power. Let me show you. So when I'm talking about stored energy, if you just think about a spring, so if you picture a spring that has been coiled down and compressed and put in a box and the box is closed, there's energy waiting to be released, yeah? So let's think of that as our muscles in the lower leg. Now, if their foot is more rigid, so let's say where the spring is resting on the floor, it's going to allow all the energy coiled up in the spring when I open the box to shoot out from a nice solid base. But if that base is not strong and rigid, then the force can dissipate, so it won't coil out as fast as possible, if that makes sense. So let's say in this position, my ankle, I'm about to set off and sprint, yeah? So right now it's just gone nice and rigid. So the muscles of the calf, of my quads up here, if you can see, they're like the stored energy. So they need a nice solid base in order for me to explode out. So if we look at the shape or a model of the foot, you can see it's kind of got a dome kind of arrangement formed by three arches. You have a medial arch on the inside of your leg, foot, a lateral arch on the outside, and a transverse arch underneath. So this particular dome arrangement creates a very strong load bearing and force distribution structure that has those elastic spring-like qualities when you also add in soft tissues, obviously. So the shape on its own is fantastic, very strong, it's great, but it wouldn't be enough to make the foot as strong as it is. So it's reinforced by things like muscles, ligaments, something called your plantar aponeurosis, and also your nervous system. So the medial arch is the higher of the two longitudinal arches, and it's strengthened by your calcaneonavicular ligament, which also blends into your deltoid ligament. And you also have your tibialis posterior muscle attachment, which connects under here and acts like a sling to pull the arch up when it's engaged. The muscles providing both structure and movement can be separated into intrinsic muscles, which are muscles that start and end inside the foot. So we call these muscles the local stabilizers. And then we also have extrinsic muscles. So these are muscles that start higher up in the leg but cross into the ankle and the foot. So we know these muscles, this set of muscles, to be called global movers. So stabilizers are much smaller, more intricate, and play an important role in finer controlled movements, whereas the global muscles are a bit bigger and more powerful, and they're involved in the main movement forces. So now if you look and feel your foot, you notice that the top, or the dorsal aspect, is way more bony than the bottom, or the plantar aspect of your foot. So the reason for this is that the majority of the muscles that pass underneath the foot in order to support and reinforce that dome structure that I was talking about earlier on. So they also play a role in contracting and generating force to allow you to push off the ground with this. Muscles under the foot are arranged into layers. You've got a superficial layer, a middle layer, and a deep layer. So the layers are actually in alignment with the foot arches that we were talking about earlier on. So the more superficial muscles, so the muscles closer to the skin, they follow the medial and the lateral longitudinal directions. And the deeper muscles follow the transverse arch alignment. So you also have nerve structures located in your muscles, your tendons, your ligaments, your skin, your joint capsule. All these provide feedback to your spinal cord and your brain regarding the position of your foot at any given moment, whether it's on the ground, running, all those sorts of things. And it's this that helps to create such a stable and solid and mobile structure. So your static, dynamic, and neural components, they all work together to provide a super efficient base. Okay, so now looking back at our foot, we can subdivide the foot into three regions, or three joints. So the first is the hind or the rear foot, and that's made up of your talocrural joint and your subtalar joint as well. Then we have the midfoot, and that's also called your chopper, and that's made up of your mid-tarsal joints. and that's also including the talar navicular and the calcaneal navicular joint. And then we have the forefoot, or the front of your foot, also known as the Lisfranc. So that's got three. It's got your tarsal metatarsal joints, your metatarsal phalangeal joints, and your IP joints, your interphalangeal joints. And obviously as well, each joint articulation has its own ligamentous attachments to reinforce it. So yeah, that's basically the shape and structure of your foot. And also just depending on your alignment, your muscular recruitment, and in what order and what dysfunctions you might have, your foot will adopt its own kind of posture. There's generally three main posture types of your foot, so being the neutral foot, flat foot, or high arches. And I'll talk about how you can determine your foot posture in the next video and what it might mean for you. Deuces.